welcome back to Verse. Have you ever wondered about moving instantly through time and space? Have you ever wondered what an atom looks like while it's moving through a wall? Today we have Dr. Shohini Ghose. Dr. Ghose is a professor of physics and quantum computing science. Her studies help us understand more about how the universe works and how teleportation might work in the future. Dr. Ghose? Dr. Ghose?
Maya, hi Maya. Maya, where'd you go?
Here, we're in the same time and place. Dr. Ghose, I know you're super good at explaining science to people, and you love to teach. So could that little trick that we just did using the cameras really happen one day in real life? Could we teleport in and out of this studio?
Well, not right now as yet, but we do actually have a possibility of doing something perhaps similar in the future, a phenomenon called quantum teleportation, where we can actually take a particle, like a quantum particle like a photon or an electron, and extract the information about that particle and send that to a distant location so we can recreate that information and have the particle teleported in that sense.
Quantum information science is pretty complicated. What got you into it, and how old were you when you really got into physics?
I was pretty young when I got drawn to physics, and I remember that there was this one year where the first Indian astronaut went to space. And I was really excited, and I really wanted to know more about how this is happening. Who is this person? And he kind of became like a hero to me. His name is Rakesh Sharma. That got me interested in science, and I started, reading all these interesting science books, and I got really into science fiction, and I decided, okay, I'm going to study science. I realized that I love physics because it really explores the fundamental laws of nature. Almost like we're like nature's detectives. Right? There are all these clues left all around us, and if we can put the clues together, we can figure out how the universe works.
That's such an inspiring story.
Oh, thank you.
Dr. Ghose, you study atoms, which are really small, and you work with computers. What are you planning to do with atoms and computers?
So atoms are the fundamental building blocks of all objects such as you and me and this table and so forth. And they obey the laws of quantum physics, which are really strange. So quantum particles like atoms have some really interesting properties which are almost like superpowers. So for example, an atom has the possibility of being in two places at the same time. And they can interact with other atoms and become locked together in this powerful connection called entanglement. So if we can harness these superpowers of atoms and control those kinds of properties, then we can build devices to do useful things like computing or communication or even teleportation. So that's why I'm interested in exploring all these powers of atoms and seeing how we can use them, not just to build devices, but also to understand all these amazing superpowers.
You've once said that atoms don't have a specific identity. They're shape-shifting all the time. Can you tell me more?
Yes, so this is yet another one of these interesting superpowers that atoms and other quantum particles have. It's this idea called quantum uncertainty, where we cannot know all of the properties of this quantum particle. So if we want to know precisely where the particle is located, we don't know where it's going to go next, or which direction, how fast it's moving. And if we know exactly how fast it's moving, it's like we won't be able to know where exactly it is. It's like having a faulty GPS, right? You can look at your GPS, you know where you are, and you know which way you're going, but not in the quantum world. And that's why it's a very interesting idea to think of not knowing everything. Not because we don't have a good enough GPS, but it's because it's not knowable. And you might think, okay, that makes things difficult, because if you don't know perfectly what the properties of an object is, how do we control it? How do we do something useful? Turns out not knowing is actually another way of thinking of hiding information. So in fact, there are very useful applications in privacy and in communicating in ways where nobody else can know what's going on. So you can hide information in uncertainty.
Is there any way to see an atom?
That's a great question. So how do you see something that's invisible?
Yeah.
So if you have, let's say, somebody who has this superpower, an invisible man, then you might think of trying to see footsteps in the sand, or you throw paint on them and hope that the paint sticks so you can see them. So there's these indirect ways where you can see something that's invisible. And that's what we do with atoms as well. We can make these atoms interact with things that we can see, such as light.
Oh.
And so when they interact, they leave a footprint of that interaction in the light itself. So lasers is what we use these days. And we can collect that laser light and we can analyze it and extract the information of the atoms. And then we can actually make images of what these atoms may look like in the quantum world.
Wow, that's really interesting. Dr. Ghose has brought us something to show us more about the properties of light. Shall we go and do it?
So here's a little toy for you. Do you want to turn it on?
Sure. There we go.
Yeah, so as you can see, this is a laser.
Yeah.
And we see lots of lasers everywhere, but have you ever wondered why a laser is so different from a regular light bulb? Well, the reason is that the laser is actually a quantum device. Inside there's a little crystal which is emitting light but in packages. So little particles of light that we call photons. And what you see here is a stream of those photons producing this beautiful green light. So this is really a demonstration of light behaving like a particle.
Okay.
But light can actually also behave like a wave. So one thing we know about waves, like water waves, is that they like to flow and ripple. And if water passes through a grid, what do you see?
Ripples.
Yeah.
Okay.
So if we can make light pass through a grid and ripple, then we'd say, hey, light behaves like a wave.
Yeah.
So what I have here is a grid for light, a very, very fine mesh grid, which you can't really see. We
No,
call it
you
a
can't.
diffraction grating. So if you put it in front, let's see what happens. Will light ripple?
Oh,
Look at
that's
that
really
beautiful
cool.
little ripple pattern.
It's really pretty.
Yes. So there you see it for yourself. Light is rippling just like water waves. So light is a particle and a wave.
Okay.
Pretty cool.
That's really cool. So what else did you bring?
Okay, so I brought a few more gadgets to show and demonstrate what all we can do with light.
Okay.
So because we understand the properties of light, we can control how it is transmitted and how to convert information into light and into other forms of energy as well. So here's the laser again.
Okay.
And I have these materials here. I want you to shine the laser through the material. You have it. Let's try to bend it and see. Yeah, it's what we call a waveguide. The material actually can guide the light in any direction we want.
That's really cool.
Yeah, so we can design these materials to have the right properties to reflect the light on itself so it can go in the direction we want.
That's so cool.
Yeah. And it doesn't even have to be a straight bar. You want to try this other one?
Sure.
Let's see, can we curve the light all the way through?
There we go.
You have it. And now why don't you try bending it? Yeah, you can even bend it through this material.
That's so cool.
And this is basically the principle we use to build all of our fiber optics transmission cables and send light over long distances.
That's super cool.
But we don't even need these materials. We can also send light through free space. We know that light can be transmitted. And what we can do is we can convert information into light energy and then transmit that through free space and then reconvert it back into information.
Okay.
So you have some music here and you want to
Yes.
send it maybe
Okay.
to your friend.
Sure.
Oh, so your phone is transmitting its information into the transmitter, which is then collected to the receiver.
Okay.
Let's see if we can move this further apart. And
Okay.
how far can this actually work? There you go. You're good. Well, you can see we're losing the signal
Yeah.
because this transmitter is, of course, not a very good transmitter, so it doesn't work so great over long distances. But we do know that we send information with our phones much longer distance. So you can imagine how well we can control all of these signals and how well we control light.
Dr. Ghose has worked her way up and is now at the top of her field, using math, physics, super powerful computers, and most importantly, her imagination to discover more about atoms and how our universe works. So just remember, there's a whole universe of opportunities out there, and you can reach your goals too. Thank you so much for watching Verse.